Right, you lot, you're going to be doing some moments questions today, right? Um, See on page 119, you don't have to do question 2, right? So if you do 1 and 3, there's some of these other ones I want to talk you through a little bit, because I've realised in all those examples we don't really have stuff acting at an angle, so I want to help you out with that, right? Page 120, I reckon we will leave these ones for now. Potentially we'll come back to them, but I want to get on with the exam questions first of all. Okay, I'm going to be really annoying for a lot of this. I'm sorry. I'm on page 121 here. See, this is June 2014, 5B, part 1, calculate the percentage reduction. I'm just looking at my filled in ones, and I've got like 3 different versions of an answer, which means that it's something that people struggle to understand, and that's my various variations of trying to explain it to them. That's all I'm saying for now. So this one's a wee bit of an odd one. Give it a go. Now, page 122. This one, our force and our distance are not perpendicular to each other, so we're going to have to do a wee bit of resolving. You can either resolve the force or the distance. Let's have a little look at how, right? So a 62 kilogram woman attaches the wrench to a wheel nut and finds it makes an angle of 34 degrees to the horizontal, and that's in your diagram. She finds that by standing on the extreme end of the wrench, which is at its minimum length of 32, she can just loosen the nut attached. Calculate the moment produced by this. Now, if we're, so what's that, 32 centimetres? Yeah, 32 from there to there. So generally, my preference is to resolve the force, but I'll go through both ways that you could do this. So, see, we want to get the component of this force really that's acting at 90 degrees to the distance, right? So, if this is 34 and this angle add up to give us 90, right? But this angle and this angle also add up to give us 90. So that must mean that this wee angle here is 34, which means that the component of the force that is acting here, this way, let me get a different colour. So the component of this force that's going to be acting there is her weight, so 62 multiplied by 9.81 cos 34. And it'll just be that force multiplied by that distance. I think I've helped you a wee bit too much there, but as I say, I was very aware that none of our examples had an angle. I don't believe I've never noticed that before. The other way that you could do this, right, let me just sketch this out here again. Okay, that is a terrible sketch, but this is this, and then this is her force acting down here, right? So I just put on her mass multiplied by gravity, so 62 times 9.81, and there's our wee angle 34. So if we want to just keep with the force acting this way, then it means we're going to need to get the component of this distance, which goes from here to here. So we've got wee corresponding angles here. No, not corresponding, that's alternate. So 34, that means this wee angle here is 34. So this distance is going to be 32 cos 34. So it's going to be that multiplied by that. Right, that's it, that's all I'm helping you with that one. Okay, I'm on page 123 here. This one here with the bike again, it causes issues every single year. I'm not going to give too much away, but expect to find that one tricky. I do want to say this, right? So if this is your like pedal on your bike and you're pushing down, so it's going to go round like this. If you're pushing down here, the distance is always going to be perpendicular, right? So as you go round, that wee distance is getting smaller. So think about how that's going to affect the size of the moment. On its way back up, you're not applying any force on this side. You will be on the other side, but this is just looking at one foot. So on its way back up, no force, so no moment. The little graph over the page, it's asking you to explain the shape of that. What I've just said is like my hint for that. But that's all I'm telling you for now. You can come on and ask me for help, and I will be going over these anyway, but I do want you to give it a go first of all. Let's look at the rest of these. Oh, hold on. I think that's all right. Your force and your thing here, just these two have to be perpendicular to each other, right? Hint, hint. The wee monkey one on the tree is a good one. Just add everything that you can onto this diagram as you're working through it. That's my hint for that. And let me think. I have a feeling there's something in this one here. Yeah, just be careful with whether the person's creating a clockwise or anti-clockwise, and where you're taking moments about. Okay, that's all my hints, that's it. But yeah, give me a shout if you're stuck, and I will help. All right, bye.